Wake turbulence, right? We know the conditions which cause wake turbulence, but we don't always know when it's present because we can't see it. We can guess that it's there, so we certainly can feel it on certain days that it's there. I want to show you a vortice generation video here. On this departure, watch the jet fly into the clouds. And this is one of those rare days that we can actually see the vortices. There's something visible out there for us. So taking a look at how those vortices form and rotate either clockwise or counterclockwise, depending on the wing, and a little bit of a sinking feeling. This one's even better. As you can see, there is a bit of wind drift up there. The airplane on final approach. Watch how the vortices not only sink, but also are moving with the wind. Okay, just pause that real quick. And notice the one vortice off of the left wing is moving into the flight path area very slowly, and the right wing vortice is moving downwind. So that's what they tend to do. So one vortice can certainly hang out in your landing or takeoff area based upon the wind conditions there. Notice how they're still sinking there. And not just airplanes, but also helicopters. There's a Black Hawk that was doing a low approach over the runway. We don't really teach a lot about helicopter vortices, but they are definitely dangerous, right? As we'll see with a approaching Cirrus aircraft here. This is 20 seconds after departure. On the left side of your screen, you're going to notice the Cirrus coming in and then getting into the vortice and covering an upset with too low of altitude to recover from it. Now, you know what? That's a Cirrus. That pilot walked out of that airplane, right? That is one tough bird out there. It is designed for safety. So keep that in mind. If this was a Piper or a Cessna, we would probably be pulling the pilot out, probably alive, but pulling out the pilot and not walking out. So be thankful that you have a wonderful airplane here to fly. Let's talk about these wake turbulence areas and just some facts that you ought to know. And keep in mind, this stuff can fail you on an FA check ride if you don't know this stuff. You actually have to apply it. If you're on your check ride and a jet lands and you don't avoid the vortice, or you don't know how to avoid it, your check ride is probably done at this point. So this is critical information for you. These vortices are the greatest when it's heavy, aircraft weight, clean configuration, and slow speed. So we think about departure. You got your passengers, you got your cargo, and you got your fuel. You're at your heaviest. Now, of course, these jets, they always take off dirty. Gear, flaps, slats, slots, you name it. They've got it out because those low speeds, it's critical that they develop enough lift. Okay? But the fact that we are dirty does not diminish the vortices that much. Okay? The slow speed that you're at will intensify those vortices, make a larger radius vortice that will just linger in a greater area for you. As a pilot, you have to look at jets that are taking off or landing. If they are taking off, the rotation point of that aircraft needs to be observed, and that's where you start counting the wake turbulence, or you start in your mind, you say that is where wake turbulence is occurring at that point. Not during the takeoff roll, but once the nose wheel lifts the ground. In addition to that, they do end at touchdown. Keep in mind at touchdown, that's when your jets usually get their spoilers out and start spoiling the lift anyway. So they end at the touchdown point. So those are the two key points that you have to know how to avoid. If you're in cruise flight, you have to avoid it by 1,000 feet. Okay, we'll get into top hat questions here in just a moment, but wake turbulence, uh, once reaching the ground, these vortices will, which have a rotational speed of 2 to 3 knots, will tend to move with the wind. Just as you saw in that video, how one was lingering in the flight path area, okay, that would be that one vortice because of the wind direction. It's trying to rotate and travel into the wind while the wind's trying to push it. So you can see how a light quartering wind could keep a vortice in the area. Now, the other one, you might have to worry about that from a crossing runway or a parallel runway situation, as it could travel to another runway. So you got to keep that in mind. Okay. So there's an example of a crossing runway, and closely spaced parallels would have that issue as well. All right, so let's take a peek here at some interaction with top hat. I'm going to ask you some specific questions on wake turbulence. So I'll read the question to you first before we start the timer. You get 30 seconds on this one here once I start it. Pilot in a small general aviation airplane is approaching to land after the Airbus 340 jet lands. That is flown by a professional crew, and they always maintain that 3-degree glide path, by the way. And of course, they always touch down on that 1,000-foot marker. So where should the pilot plan to fly the airplane with regards to the approach path? So large jet is approaching and you are behind that one. Okay. So how are you going to avoid the vortices of that jet? If you're having any trouble with top hat, let me know so we can get you going. Yes. Oh, yeah. Here, let me add some time on that. This is not a quiz. All right. So talk with each other. Absolutely. This is group learning. Yeah. Thanks, Alex. Wait on one more. All right, at the last second there, got it. All right, now I can look at the responses here. All of you answered the same question there, fly above the jet's approach path, and that is the correct answer. You understood that one. Awesome. Let's try another question. Oh, question first.
So say you're in IMC, you're same scenario, but you're in a general aviation aircraft, so you're gonna have less approach. So would it be wise to be like one bar high on the ILS approach if you're landing behind a heavyweight producing aircraft?
So there is going to be some spacing built in by ATC.
Okay.
So you probably don't have to worry about that on the actual approach. They will have those arrivals spaced as long as everyone's maintaining the right speed on the approach. They've got to have so many miles of separation between aircraft anyway, and so that gives you the time for vortices to dissipate normally.
One of the slides says that they generally move laterally over the ground at 2 to 3 knots. Like, what do you mean by that? Because doesn't it depend on the wind in the situation?
That's right. Yeah. So I'll bring up that slide for you. It has a rotational speed of 2 to 3 knots. So in a calm wind situation, it would be traveling at 2 to 3 knots over the ground. Yeah, the wind is either going to help it move or hinder its movement. So just imagine you got a 3-knot wind out there and your vortice is traveling at 3 knots. It's just sitting there. One of them, right? This one's just sitting there, whereas the other one would be traveling at 6 knots across the ground. All right, so let's look at specific avoidance techniques here. Obviously, en route, we would avoid the wake by 1,000 feet. But coming in for a landing, you'll quickly run out of 1,000 feet before you hit the ground. So you have to land the aircraft beyond its touchdown point. Think of that red area up there as the danger zone, right? That's where all the vortices are going to be. And then once we hit the touchdown point here, vortices end. Right? So as a general aviation pilot, if you were landing, you would be landing beyond the touchdown point. Or if you're departing, you would be departing, rotating beyond the touchdown point of the jet there. So let's try and reinforce that with the top hat question here. So small general aviation airplane on short final to land after the Airbus 340 jet lands. Okay, remember that jet's going to land, follow that glide slope and land on the 1,000-foot marker. Where should the pilot plan to touch down? Okay, so talk among yourselves. So you got 30 seconds. All right, here we got a response in, and all of you agree to touch down after the jet's touchdown point. Very nice. I'm glad you're understanding this. This is all critical, so good. Next question. Small GA airplane planning to depart after the Airbus 340 jet lands. You're departing, it's landing. Where should you plan to rotate? All right, so a little split here. Most of you chose to rotate after the touchdown point, okay? And that is the correct answer. Okay? Rotating prior to the 1,000-foot marker, because that's where the jet's landing, that is the danger zone. Okay? It would all be red area, all beneath that blue line right there. So you're departing, you have to make sure you are past its touchdown point before you rotate there. Looking at departure now for a jet. We need to avoid the area behind the jet, okay? And we need to avoid 1,000 feet below it. It's kind of hard on departure, right? As it's leaving the ground, you can't be 1,000 feet below it, right? So you have to be able to avoid its vortice until you're at a safe altitude. While it's on its ground roll here, there's no vortices. Right? It's not till its rotation point here, when there's enough lift to make the nose wheel leave the ground, that we have the danger zone begin. And then this red path here is its departure path, and everything below that area is going to be the danger zone itself. Okay. Let's take a peek at another top hat question on this area. A small GA airplane planning to depart after the Airbus 340 jet departs. Where should the pilot plan to rotate the airplane? It departed, you're departing behind it. You're trying to avoid the danger zone. All of you said to rotate prior, and that is the correct answer. Very nice. Great example right here. Watching the jet, rotation. somewhere around the Gulf taxiway. There we go. All right, another one. Small general aviation airplane approaching to land after the Airbus 340 jet departs. So jet departed, you're landing. Where should you plan your touchdown point? All right, you all are thinking very well this morning. Despite the early hour, your brains are fully engaged. Well done.